So we now look at the types of polymerization. So we already know that polymerization is the process of forming large molecules from smaller molecules that we call monomers. Okay? So we have two types of polymerization: addition polymerization and condensation polymerization. So we start with addition polymerization. So with addition polymerization, what you are basically having monomers that are unsaturated. Monomers must be unsaturated. That's the one unique property that you should always have in mind. Unsaturated, in this case, the meaning of this is that you have double bonds in the monomers, double bonds in the monomer molecules. Okay? So when they combine, they form a large single molecule without producing any other product. Okay? Whereas for condensation, we shall see that we are combining monomers that are saturated, forming a large molecule, but we get other products. We shall look at that. So these additional polymers can also be called chain growth polymers. It's just adding the same repeating units to a growing chain. Okay, so rubber and plastics are examples of additional polymers. So because we are adding the same repeating units, usually the polymer, the large polymer will have the same empirical formula as the monomer. This is something that you learn in future. So polythene is an example here. Which polythene is made from ethene. Okay, so the examples of addition polymers, the polyethylene that I've talked about, you can also call it polyethylene. The monomer is ethene. This one is unsaturated. And the polythene can be used for as plastic bags, bottles, containers. And then we have polypropylene, PP. This one is also unsaturated. The monomer is unsaturated and is propene. You can also call it propylene. You can also call it propylene. So again, the purposes I use for making packaging materials, textile, automotive parts, and then the PVC, polyvinyl chloride. The monomer is vinyl chloride and is mainly used in making pipes, window frames, and medical tubings. And then the last addition polymer that we're talking about here is polystyrene, PS. The monomer is styrene, and we use them for making foam cups, packaging, and insulation. So condensation, polymerization, the key thing is that you are having monomers that are not usually the same. The monomers that are combining to form the polymer, these monomers are different. And because they are different, we are calling them different bifunctional monomers. Bifunctional monomers. So the meaning of this is that the monomers have two functional groups. Bifunctional, they have two functional groups. So A functional group is a group of atoms that define the characteristics of the molecule that has them. Okay? So as a result, you usually have byproducts. So these byproducts can be ammonia, can be water, can be hydrogen chloride. Remember, in addition, polymerization, we studied there is no any other product given out. In condensation reaction, polymerization, we are saying that smaller molecules are given out, and it can be ammonia, it can be water, it can be hydrogen chloride. So, because you're combining different monomers, the monomers are not the same. You cannot have the polymer having the same empirical formulas like the monomers. It is not possible. So, nylon is a condensation polymer, and this nylon is made from diamines. So that means that the amine that you're talking about here has two amino groups, and these amino groups are the functional groups you're talking about here. And then here we're also talking about dicarboxylic acids. So that means that you have carboxylic acids. You have the carboxylic acid here having two functional groups. Okay? So here we are. What do you notice? The first thing you notice is that we have byproducts. Okay, so the byproducts can be water, can be ammonia, can be hydrogen chloride, or can be any other byproduct. The second thing that you should notice is that we are not talking about a single monomer for each of these polymer. At least two. At least two. So you can see that here we are having hexamethylene diamine plus a dipartic acid. So you have two here. And then also here we have two, here we have two. It's only here that we are not having two. Okay, so nylon, we have nylon 6,6 and then we have nylon 6. These are different. These are different. Okay, and then we have polycarbonate, and then we have styrene, which is PET. Okay, so the uses are here. We already looked at nylon earlier on. We said it is used in textile, it is used for making ropes, fiber, carpets, and clothing. That is nylon in general. But when we go and specify nylon 6,6 and nylon 6, we're talking about different uses there.